Hello guys, welcome back to my channel. And I know it's been ages since I made a video on integration. So let's do one today, right now. Okay, so we have to evaluate this integral and I'm calling it I. And I'm gonna use Feynman trick or Leibniz rule of differentiating under the integral sign. So the integral from minus infinity to infinity e to the negative x squared over x squared plus 1, and then I'm going to take this extra factor of e to the negative b times the denominator x squared plus 1, and you will see why I took the denominator. That's because when I differentiate with respect to b, the denominator is going to cancel out, and I took a negative on top so that this integral converges, this I of b function converges. Okay, so now let's differentiate with respect to b. We will simply get e to the negative x squared over x squared plus 1, and we have a negative e to the negative b times x squared plus 1, and then this coefficient with respect to b, which is x squared plus 1 dx. Notice this cancels out with that, and we're just left with negative. We can take an e to the negative b outside. Integral from minus infinity to infinity, e to the negative x squared e to the negative bx squared dx. Now group some terms in the argument of that exponential function, e to the negative x squared times b plus 1 dx. And notice that this is just the Gaussian integral, but with this factor in the argument. So that extra factor just comes, we divide the square root of that factor, and then just the regular value of the Gaussian integral, which is square root of pi. That's the value of I prime of b. Now we need to integrate with respect to b so that we get I of b back again, because by the fundamental theorem of single variable calculus, at least that's the way I like to put it, I prime of b db will equal I of b plus some constant of integration. So to get rid of that constant of integration, which is imminent, we need to have upper and lower bound. We need to make this a definite integral. So what are two simple values of b where I of b becomes something simple? Well, look for what values of b make I of b go to 0. Well, if you notice, if you take b as b tends to infinity, this top term, this negative exponential, will decay and make this entire I of b go to 0. So take that. Actually infinity, as I discussed, b goes to infinity, and 0 value is what we need, because when b is 0, this exponential term that we introduced goes to 1, and we end up with the I, the original I that we had, the question that we had to calculate. That's why I took a 0 and I took an infinity, because that will just become I as b tends to infinity minus I of 0. I as b tends to infinity, as I discussed, is 0 minus the original integral that we had to calculate. So now I prime of b is just this guy, we calculated that on top. Negative integral from 0 to infinity e to the negative b over square root of b plus 1 times square root of pi db is negative the question that we had to calculate. Cancel out the negatives, so I just becomes square root of pi integral from 0 to infinity e to the negative b over square root of b plus 1 db. Now introducing a substitution isn't something remarkable or something that you wouldn't consider. 2v dv is db, and the upper and lower bounds change accordingly, and they become going from 1 to infinity. We have e to the negative, b becomes v squared minus 1 over v, db is 2v dv. Cancel out the v's, take the 2 outside, and the e to the positive 1, which will just be a e, and integral from 1 to infinity e to the negative v squared dv. Now this looks like the error function, the Gaussian error function, but there's like a catch there, because remember the Gaussian error function at x was 2 over square root of pi integral from 0 to x e to the negative t squared dt. The elementary error function ERFC of x was 2 over square root of pi integral from x to infinity of e to the negative t squared dt. And we call it the complementary error functions because if you add both of them, ERF of x plus ERFC of x, you get 1. You can check that out, using the Gaussian integral and then extending it from 0 to infinity basically. Here we have the complementary error function, because you think of, instead of x having a 1 there, so ERFC of 1. But we need this other factor to 2 over square root of pi. So I'll just have to multiply and divide by that. When I do that, the 2's cancel out. Square root of pi becomes a whole pi. So pi e, and then this guy entirely just becomes complementary error function evaluated at 1. And that is precisely the answer for I. Believe it or not, it's a weird answer with a non-elementary function. But that's it, yeah. That's it for this video. Please like, share and subscribe to my channel, guys. Recommend me to your friends. Spread the word of Gamma Digamma in the math community, and in the meantime, stay home, stay safe, keep doing math, and peace out.